All right, you okay? Negative 59 pi over 6. How does that work? Well, I'm just going to go straight. I'm going to just work within radians just to keep it quicker and simpler. So in other words, I'm just going to add a bunch of 2 pi's. I'm going to convert them all to 12 pi over 6 in a minute. But you get the idea. If you just keep adding 360s, you're at the same place in the circle. Am I making any sense, right? So if I have a unit circle, if I have a circle, well, yeah, here I haven't been saying it that way, have I? Let me stay with the way I've been talking. So if we have a place, I don't even know where this is. Suppose it's like right there. I don't even know. Suppose that, negative 59 pi over 6, that's some huge negative angle, right? So that means that I don't know where it is yet. I have no idea. But that means they started here and they went negative, right? You always start right there, don't you? That's 0. Right, this is 0 degrees. So they started there and they went negative, they went down, and they went around and around and around and I don't know how many times, and maybe they stopped there. I have no idea if that's right or not. But they stopped somewhere, right, after going round and round and round and round several times. Well, I'm going to basically unwind all those extra roundy rounds, which are 360s, aren't they? They're full 360s, or full 2 pi's if you're talking radians. Making sense? So every time I add a 2 pi, I'm unwinding it one time, unwinding it to get back, because that's what they want from me, is they want me to give them just the regular angle somewhere within one full circle instead of more than one full circle. All right, so just add a bunch of 2 pi's, or 360 if you convert it to degrees, either way. But I can't do 2 pi, I got to get common denominator, so I'm going to make all those 2 pi's be common denominator, so that means 12 pi over 6, doesn't it? Those are 2 pi's. Every time you add 12 pi over 6, that's 2 pi, isn't it? All right, so I'm just going to keep adding 12 pi over 6. So if I add 12 pi over 6 once, what do I get? Negative, what is that, 47 pi over 6? Keep going. I'm still very negative. I'm going to add, in fact, let me just add a couple of them now. I'm going to add 12 pi over 6, 12 pi, that's 24. So that'll leave me negative 23 pi over 6. Oh, I'm going to add 2 more. You can tell it's just 2 more, huh? 12 pi over 6, 12 pi over 6. That's 1. Positive 1 pi over 6, or just pi over 6. That's the answer. Does that make sense? Is that too quick? Does that make sense what I did there? So I just kept unwinding it by adding full circles. 360, 12 pi over 6, 2 pi. So every time I added 12 pi, negative 59 plus 12, you can use calculator, be negative 47. Then I just added a couple more 12 pi's, a couple more full circles. That's negative 47 plus 12 is negative 23. Plus 12, that's 24. 24 minus 23 is 1 pi over 6. There's where I first got a positive answer within one full circle. That's what they want. So it's pi over 6. I don't know if you're comfortable yet with where pi over 6 is, but that's right here. It's 30 degrees. That's where it ends up. That's the final answer they want there. Make sense on that? Questions I can answer? How we did that? Yeah.
So you're just trying to get to the positive?
Yeah, what they're saying is they find a positive angle less than 2 pi, so within one full circle. Does that make sense? So it's kind of like, maybe I could make it more simple. If somebody gave me and said, hey, I'm gonna go negative 400. Negative 400 degrees. Well, what is that? Well, that's a full negative, going negative, or going down first. That's a full negative 360. And negative 40 more, isn't it? Just to give a simpler number, to make sure you're getting the idea. That's negative 360 and negative 40 more. So in other words, it's the same as just negative 40, right? You with me on that? That extra 360 doesn't matter. So you see, if I took the answer, the original question, I mean, negative 4, what if they gave me negative, I'm just going to try to make the question simpler here. What if they gave me negative 400 and I just added 360? What would I get? Negative 40. Do you see how that would give you the same answer and I just unwound one of a full circle, right? Now, I couldn't stop there because they actually want a positive answer. How about I turn negative 40 into a positive answer? Well, you just add another 360. Anytime you add 360, you see you're at the same place in the circle. Does that make sense? You're just adding one full loop. So wherever you're at, you haven't moved anywhere other than added a full circle. So you can add 360s all day long or subtract 360s all day long. You're at the same spot on the graph, aren't you? Everybody get that idea? So I would just take negative 40 and add another 360, and that would be what? 320? 320. That would be the answer they would want if they gave me negative 400 as the original question. It would end up to be the same spot as positive 320. So that's what I'm doing, but I'm doing it all in radians, right? They gave me some hugely negative radian angle, and they're saying, hey, turn it into something that's within one full circle. So I just added a bunch of 2 pi's, 12 pi over 6. Whenever you add 2 pi, whenever you add 360, you didn't really move anywhere, you just took out a loop. That's all you did. All right, I'm not sure if that's happy or not. Well, you know what? We can help each other out if you'll give me active feedback. Either way, yes or no, I'm happy. What I'm not sure, you can't give me your poker face. You can't give me the straight look. You got to give me like, no, that's not making sense. Or yeah, I'm good. Then I'll know whether to speed up or slow down or say it more or say it less. All right, yeah.
How did the problem that you just did, how did you know that the pi over 6 was right there?
Oh, that's because, I just know, but we'll get to that more. I understand you guys aren't comfortable with that yet. Pi over 6, I just know that's 180 over 6, that's 30 degrees. I was just thinking all that. Yeah, we'll get to that. I don't expect you to know that yet. And we don't have to do that yet. Finally, we are back from our problems. Little iPad. All right, so there we go. 12 to 3 o'clock, so number 24. The minute hand goes from 12 to 3, which is 1/4 of a complete revolution. So from 12 to 3 o'clock, 1/4 of a revolution. So they're asking me how many degrees is that? So if you have a clock and the minute hand goes from straight up 12 to straight over, here's 12, here's 3 o'clock. So how many degrees does it go through as it goes from 12 o'clock to 3? 90 degrees. That's a 90-degree angle, isn't it? Does that make sense? Are we good with that? And then they also want it in radians, right? Yeah, how many radians? So 90 degrees. Yeah, if you just know it's pi over 2, great. If not, you can do the formal conversion. How would you formally convert? Remember, the conversion between degrees and radians is pi over 180 or 180 over pi. How do you know which way? Well, you got to put the degrees on the bottom because you want degrees to cancel, right? You want degrees to cancel. You want to go from degrees, out of degrees, into radians. So put them on the bottom so they cancel. And so then that's 90 pi over 180. Then 90 goes to 180 2 times, pi over 2 radians. So the two answers they're looking for on that question, 90 degrees and pi over 2 radians as the clock goes from 12 to 3. We good with all that? All right, we'll keep moving. All right, so here we are with another one showing it's basically showing a railroad crossing sign, and it's going to tell us that the radius is 22 inches. So let me just draw it right here. Oops, I probably should have drawn the circle first. Okay, there we go. All right, so they're giving me that picture, and they're telling me right here it says the radius is 22 inches. So that means that's 22, right? Or any of those little legs is 22. A radius is from the middle to the edge anywhere, right? So from the middle to the edge is 22 inches, and they're asking me if the radius of the circle is 22, find the length of each of the 4 arcs. So in other words, how long is this arc? How long is that? How do you figure that out? Yeah, remember we have an arc length formula, right? What's the arc length formula? radius times theta. Remember that? Radius times theta, arc length, I think we called it S, whatever you want to call it. It's R times theta, radius times arc length. And so there's one important thing about using that formula. What's that? Yeah, radians only. So, okay, R, this is R. And theta, what's theta? What's the angle? Well, the angle's right here. You with me? The angle is the angle of the opening of the angle that leads to the arc. I could have done it for any of the four of them. I just did the top one. Right? So the amount of opening, the how big the angle is that leads to that arc is what? What is that angle? It's 90 degrees, isn't it? Because if you read the words here, they say the two lines are meeting, at a 90-degree angle. So it's 90-degree angle. So can I put in 90? It's got to be radians, huh? It's got to be radians. So you take 90 degrees, you convert it to radians. We just did that. It's pi over 2. I'll do it again real quick. You multiply by pi radians over 180. These cancel. 90 pi over 180. Pi over 2. So yeah, you stick in pi over 2 here, like that. Then you work that out. So 22 times pi over 2. So what happens there? You put the 22 over 1. 2 goes into 22 11 times. It's 11 pi. There's the answer they want. That's how long this arc is. It's 11 pi. And so they ask you for that. They ask you for the length in terms of pi. So that would be 11 pi. Notice down here it says 1 part remaining. The second part they're going to ask you to give the answer in a decimal. So how would you take 11 pi and make it a decimal answer? Yeah, you just plug in pi, huh? 3.14. You can use I don't know how much accuracy they want. If they want more accuracy, you can use the pi button on your calculator, which goes further.
Make sure you do it to the 5th decimal.
Yeah, whatever they're asking, I don't even want to mess around. You guys can straighten all that out. I got bigger fish to fry than to fool around with that. But yeah, just multiply that, get your answer there, and write that in. Is that good for those two parts? So it's going to be 33 something, isn't it? 33, 34, I don't know. That's how many inches that arc is. So you can actually find how big a piece of an arc is that way using the formula radius times arc length. That's not right. Radius times angle. Like that. We good? So you got a little picture of the globe there, of the Earth. And they're taking that central angle. I don't know if you can see that picture very well. I could probably make it big. Let's do that. All right. Can you see? It's a little blurry now, huh? Can you see that angle C is like the center of the Earth? So that's coming down from the center of the Earth, and then this angle is coming up, 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 and there's some arc thing there. Everybody see that? So here's the center. This dot is the center of the Earth. This is some angle theta here. That, some opening angle theta. And they're telling me, well, in fact, I forgot, what is it they're telling me? They're telling me 4,000 miles. They're saying, the radius of the Earth is 4,000 miles, and the two cities are 8,000 miles apart. Okay, so these two cities are 8,000 miles apart, and the radius of the Earth is 4,000 miles. Is that right? Radius 4,000, 2,000, yeah. So that means so the radius of the Earth is very close to 4,000 miles. So from the center of the Earth to the edge, to the surface, anywhere, is about 4,000 miles. And these two cities, A and B, are 8,000 miles apart. So if you think about it, distance on the Earth is technically an arc, isn't it? Distances aren't really a straight line in the sense of being a flat line, because now we know very clearly the Earth is not flat, right? The Earth is round. So that debate's over for most people. So the Earth is curved, and so really distances on the Earth are arcs, aren't they? They're arcs. So that's 8,000 miles. So can I find the angle? So if you're in two cities that are 8,000 miles apart, how much angle apart are you as the angle is measured from the center of the Earth? Could we figure that out? How would we find that angle? What are we going to use? Arc length, S, is r theta again, huh? Same formula again. The arc, this is the arc right here, that's the 8,000, is the radius, that's the 4,000, times theta. Does that make sense there? Do you ever think about distances between two cities on the Earth as arc length? 4,000. And theta is 2. 2 what? 2. Good. Yeah, do you realize that's radians? That's 2 radians. How do we know it's radians?
Because it has to be.
Because when you use that formula, automatically the angles are in radians, not degrees, remember? I keep beating that drum. I hope that is coming across clearly. So that must be 2 radians, not 2 degrees, because the arc length formula is automatically in terms of radians, isn't it? Now on this question, they're also going to ask me to give the answer in degrees. First they want it in radians. There's the answer in radians. And then they're going to say, give us the answer in terms of degrees. So I'll convert 2 radians to degrees. So how do I convert that to degrees?
180 over 5.
Yeah, you multiply by, see, where am I going to want radians? I want radians on the bottom. So pi radians, 180 degrees. Everybody see how I decided which way to put that 180 pi fraction? Remember how you know that? Like I learned from chemistry, you want the units to cancel, right? Because this is over 1. So I want radians to cancel. That's how I knew to put radians on the bottom. So they would cross cancel. And I would then be in degrees, right? See, radians are gone, and I'll be in degrees. I will have converted to degrees. And so what will that be? That'll be 2 times 180. What's that? 360 degrees over pi. And you need to actually divide that on your calculator. You know, put in 3.14 here. Or even more accuracy, if you want to use the pi button. Probably the easiest thing, probably just use your pi button on your calculator. Have a whole bunch of accuracy that way. So 3 here, I'll use my pi button. 360 divided by pi. Where is my pi button? Oh, there it is. All right. Oops. Divided by pi. I'm getting 114. I don't know how much accuracy they want. I'll just say 0.59 degrees. 114.59. Y'all able to get that on your calculator and everything? If you have any calculator troubles, just grab me after class. It's usually 10 seconds. I'll show you where the pi button is or whatever you need. I'm glad to help with that. Just run up for 10 seconds before you take off. Any calculator issues as we go day by day. Any questions on that one? Is that okay? That makes sense what I did? So again, I just used the arc length formula. R theta, solve for theta, 2. It always comes out radians at first. And then I converted, which means you get rid of radians. Put radians down below. Use the pi 180 conversion. Got 360 over pi. Plugged in the pi, 114.59 degrees. So that's the angle from the center of the Earth between two cities 8,000 miles apart. They have a 114 degree angle. All right. A little physics here. You all going to take physics? Because they do angular speed and stuff like that in physics. So angular speed of a point on a planet is 5 pi over 12 radians per hour. The equator lies on a circle of radius approximately 4,000 miles. That's our planet. Find the linear velocity. See, it's off the screen there. Find the linear velocity. I don't know. I can't read it, but something per hour of a point on the equator. Okay, so that's a lot of fancy talk. Let me make it simpler for you. So 5 pi over 12. Notice the units. I survived physics by paying attention to units. Units are so helpful. And I used to, before I took physics, I didn't really like units. They kind of bugged me. I wish they weren't there. But then when I took physics and I read all these really hard words, physics was about the hardest thing I did. Certainly at junior college. Physics was the hardest thing I did at junior college before I transferred. Physics is like math with all word problems. That's what physics is, basically. And it was hard. I read a lot of hard word problems when I took physics. I took the calc-based physics at junior college, and so I already done calc, and then I took the physics using that calc. And I would read these crazy word problems, and I would go, I have no idea. But then I would look at the units, and I go, okay, I'm just going to follow the units like following the yellow brick road. And I would go, okay, well, it says 5 pi over 12 radians per hour. Per means a fraction, right? Radians per hour. Watch, let me just write, I won't even pay attention to anything else. I'm just going to write down those units, 5 pi over 12 radians per hour. And they want me to convert it to velocity. Velocity is going to be in miles per hour. Miles per hour. So basically, I have to convert from radians to miles. That's really what's going on here. Does that make sense? The whole name of the game, what they're asking me to do on this problem, they're saying there's a point, as the Earth rotates, they're saying there's a point on the Earth, and it's rotating 5 pi over 12 radians per hour. That's how fast the angle's moving. Does that make sense? That'd be like if I took my hand and I said, all right, the tip of my finger from my elbow, the tip of my finger here, I'm going to move it, let's say, what would this be, 90 degrees from flat to straight up? That'd be nice. I'm going to move it 90 degrees in 5 seconds. Ready? Go. 1, 2, 3, 4, 5. There we go. I just rotated the tip of my finger 90 degrees, and I did it in 5 seconds, right? So that's an angular speed. You getting the feel of that? That's how fast an angle is changing, right? Or I could stand here and say, I'm going to rotate 360 degrees in 5 seconds. Hope I don't get dizzy. Here we go. So I'm doing the trigonometry dance here. All right, so I just rotated 360 degrees in 5 seconds. That's an angular speed because it's angle per time. Like you could do a homework speed. I can solve 17 problems per hour. That would be your homework speed, right? So anytime we say a speed or a rate, it means times on the bottom, doesn't it? You with me on that? Okay, so with that firmly in mind, angular speed is angle per time. They want me to change it. Now what if I asked, when I did my elbow and I went 90 degrees, how far, what if there was a little ant sitting on the tip of my finger as I did that rotation? How far did that ant move? What was the speed that ant would be moving through the air? I'm talking regular speed now. We know he's going 90 degrees in 5 seconds. That's his angular speed. But I mean, how far is that arc? He's actually moving a distance. I don't know, what does that look like? That maybe 12 inches or something? I'm guessing, looks like about 12 inches in 5 seconds. That would be a linear speed, right? In a line, not an angle. Even though it's curved line, it just means not an angle. You with me on that? There is one more seat here if you want that. So is that making sense? So that's what they're asking us to do here, is convert between an angular speed and a linear speed. Like that little ant on the tip of my finger here, it moved 90 degrees in 5 seconds, but how many inches did it actually go in 5 seconds? Well, to convert that, I would need to turn the angle into the arc length, wouldn't I? That's all they're really asking. Are you seeing that? So, radians per hour, that's like degrees per hour, except it's in radians. It's an angular speed. Convert it to actual distance. Well, how do you do that? Well, it's the same thing as the Earth problem we just did. The radius is 4,000. So you just got to take 5 pi over 12, which is the angle, right? We're just going to use the S equals R theta thing again. The S is the arc length. I'm just going to say arc length is R theta. And I'm going to say, okay, take the R, the radius. They told me that's 4,000 miles for the radius. And what's the angle? But instead of angle, it's angular speed. Same thing. 5 pi over 12 radians per hour. It is, by the way, it is in radians. If it was degrees, I'd have to change to radians, right? But it's all radians for me. That's the, instead of the angle, it's the angular speed. Same thing though. And that'll give me, instead of the arc, it'll give me the linear speed, or the arc speed. Does that help? You can call it arc speed if you want. Same thing. So it's the same formula. Bunch of fancy talk for same formula. You're converting an angle to a distance. It's an arc. So hit the buttons on your calculator. That'll be it. Does that make sense on that? Questions on that? We did a little physics even. I like physics. I like physics a lot. I didn't like chemistry so well, but I liked physics. Physics is very mathematical. It seemed interesting to me. All right. On we go. I'm going to leave that behind if that's okay.